Hello, everyone. Thank you for joining this bootcamp. And yeah, let me start sharing my presentation. Yeah, I believe this is it. And I'm ready to start. I hope that you are all ready too. And our today's topic is prompt engineering. This is very important topic, very interesting topic. And I hope that this session will be equally relevant and useful for those of you who never ever tried to do something with the prompts. But my assumption that pretty much 100% of people in this virtual room are at least tried to communicate with ChatGPT or similar services. That means that you already at least junior prompt engineers, and equally interesting and relevant for people who work with building AI infused applications, because we'll start from the very basics and we'll dive deeper into some technical topics. Let me scroll to the next slide. Who am I? I'm Maxim Salikov, like I was introduced. And I work in Microsoft, specifically in our Microsoft Western European organization. I'm based in Oslo, Norway, and I stream live from this amazing and beautiful city. In Microsoft, what I do, I help developers to succeed with AI, with our cloud and developer tools. And I'm a very technical person myself. Actually, I develop for decades, and I started to build different web projects late 90s of the last century. And also, I'm a huge fan of the developer communities or technical communities. And this is why I, without too much thoughts, confirmed and agreed to participate in this call, because sharing is caring. And I really love to share what I know, what kind of knowledge, what kind of skills. And of course, every single time I present, I also learn something from the audience. So I hope that we'll have interesting Q&A session. And my favorite topics are web development. So this is where my main development skills are applied, everything around cloud, generative AI, and of course, prompt engineering. And as you see on the screen, I'm also interested in music, and in particularly, I'm interested in AI-generated music. So I delivered a few DJ sets that consist only of AI-generated house and techno tunes, tracks. Yeah, that was an interesting experience. And yeah, if you are interested in music as well, I encourage you to look at what AI brings to the table here. But let's start. 1 billion of people on our planet are users of generative AI. Of course, we can dive deep into definition of what is actually user of generative AI and other like constant users or just one-time users. Doesn't matter in this context. This is just incredible number of people. And folks, this is very conservative estimation. I mean, I went through multiple articles and research done on the topic, and this is the least number I found in this research. I mean, in reality, it's well over 1 billion. And that means that generative AI is hugely and widely adopted, and adopted super fast. I mean, if we talk beyond like data science audience, data engineers and AI and machine learning experts, who, of course, who are in this topic for quite a few years, in a while, for broad audience, term generative AI became known maybe not later than November of 2022, when ChatGPT was released. I mean, it's still very new topic, very cutting edge topic with such a huge adoption. Who are all these people? All these 1 billion. I mean, what do they use? What do we, after all, we are also users, right? What do we use generative AI for? I really want to have this kind of intro before we dive deeper into how to use this. And of course, this is all interconnected, right? How we use this depends directly on what we use this for. And I identified three large and actually intersecting circles. First of all, it's all around being more productive. Being more productive as employee, being more productive as, I don't know, family person, being more productive as scientist and educator. So it's all about boosting our like humans level to some next level. Next huge application area is all around creativity. When we don't think about, yeah, we do something faster or better. No, when we want to express our feelings in form of video or audio or image or text. Generative AI, after all, it's called generative, is perfect for creating, for generating something. And of course, you want to control, you want to steer how it generates things. And again, we go closer and closer to prompt engineering topic. And last but not least, it's for people, for experts who build applications. I mean, maybe this is not that large circle compared to all like personal and business productivity and creativity. I mean, there are tens of millions of developers in the world, but again, compared to 1 billion, this is relatively small group of people, right? But anyway, these are people who actually build applications for productivity, for creativity, and other applications. This is why it's extremely important group of people, and this is where you want to have full control over generative AI. And this is where we actually double click in today's session. So in this session, do not expect prompts that will explain you how to create this or that picture or how to create this or that document. No, we'll focus on prompts that you use for building applications. And yeah, I already named what's common among all these applications. And if you look again at the example how you generate picture using Midjourney or any other generative AI image, text-to-image generation, or how you start your smart template in Microsoft Word, or how you communicate with GitHub Copilot, another amazing example of generative AI specifically for the developer audience, or last but not least, how you communicate with ChatGPT and plethora of similar services. One common thing, prompt. This is something that we write using our language, natural language, human language. In many cases, English language, but of course, it's not a limitation at all. I mean, you can use a variety of human language to successfully communicate with AI. And so we went through very different kinds of applications where you can use generative AI superpower. We also went through one common thing, prompt. If we look at this field from slightly different perspective, there is also emerging set of the models. I mean, if we go a bit on more technical level, behind every customer-facing service that exposed for a broad audience, like generate text or image or whatever, there is particular model, right? And of course, if we specifically talk about how we build LLM or large language model infused applications, yeah, we need to communicate with concrete model or models, and they are all very different. Some of these models are huge, and this is why after all they called large language models. I don't know, like billions, trillions of parameters. We are not going to let's say data science level in this session, but in a simple words, the more parameters model has, the smarter it is. So large language models. Now we see rise of SLMs, small language models, like family of 5 models exposed by Microsoft. Still capable model, of course, to not that extent like family of GPT, but still relevant enough for variety of use cases. And at the same time, you can host this model straight on the user device, straight on, for example, mobile phone, or not even saying about desktop application. And of course, it unlocks completely new scenarios. Different angle how we look at the models. Some of them are let's say general knowledge models. They know about pretty much everything they could gather on internet. Some of them are highly specialized. For example, model that knows specifically everything about biomolecular science. I mean, don't ever try to ask this model to generate songs for you, but ChatGPT cannot compete with this model in this specific domain of knowledge. Then another dimension of the models, single modality, when model accepts, for example, only text or only image or only sound. Of course, it's like mainstream is text, right? I believe 99% of single modality models are about text, versus multimodality. And here I want to emphasize recent announcement of GPT-4o, and O means omni, and omni means let's say like multimodality in this context. These particular model accepts text, image, video, sound all at the same time, and accepts all these different ways to communicate natively. I mean, you don't need to have forefront before this model that, for example, transcribes your speech to text. No, you just stream all these sources of information directly to the API and receive response. Of course, it's smarter, it's faster, and after all, more developer friendly. So how do we control, how do we steer all this variety of use cases, variety of models? Of course, we use prompt engineering. And I find this quite ironic that in order to control the most advanced artificial intelligence we have on our planet so far, and generative AI is definitely the most advanced one, we have to use not any kind of formalized language or programming language or something like kind of strictly defined. No, we must use, and basically this is the only mainstream way to use these models, our language, human language, natural language. And yeah, the devil is in the details, like always, and I'll explain you all the small tips and tricks and the techniques and methodologies how you can be more efficient in communicating with the models. Again, I'll try to make this narrative relevant for everyone, but specifically it's tailored for people who are building LLM infused applications or maybe plan to build this application. So my personal hope is that I will inspire someone on the call to go and try some code to communicate with these models. And I mean, code is just a code, and communicating with these models are not that technically sophisticated. In many cases, this is just calling API endpoint, getting something back. But again, what exactly you send as a payload of your call and what kind of prompt exactly, this is where all the magic is hidden. So what is prompt engineering? I define it for myself as a process. I mean, this is not something like you created prompt, you forgot about this. No, this is process of designing, then refining, and then optimizing prompts to control model, to guide model towards producing results that you expect, that you you estimate, and at the same time you keep cost efficiency, because there are multiple, let's say, different pricing scenarios when you interact with large language models, and prompt engineering affects this directly. Okay, now we are ready to look at contents of pretty much generic and regular prompt. We can call this prompt anatomy. And imagine we are developers. We are people who build, for example, solution for marketing automation. I believe marketing automation is one of the lowest hanging fruits in generative AI fields. I see startups appear in this field every single day, and very interesting ones. And I assume many of them will be successful ones. So we want to help our customers to automate, write something, right? And for example, let's look at customer-facing scenario. We want to get support from the generative AI in writing product launch email for some product. Let's imagine these are new headphones. And what kind of prompt do we want to send to API endpoint that exposes one of the models we mentioned earlier? What you see on the screen now, of course, it's always has some instruction. And in this case, in this scenario, it's very explicit one with write directly, write product launch, blah, blah, blah. In some cases, maybe not super relevant for enterprise scenarios, but instruction can be something less visible. And maybe you know how LLM works. They don't care about if you directly ask something or just start the sentence. They will just continue the sentence, right? So this is the nature of how LLM work. But in this case, and in enterprise scenarios, of course, we want to be as clear as possible, as precise as possible. Definitely, we want to provide some input data. If you talk about headphones, we definitely have some parameters around that, including pricing, including some features. Also, we might want to provide we can call this secondary data or context, and it's about, for example, tone we expect, or tonality, or you name it. In this case, we ask to be friendly and exciting. In some cases, we can ask to be more authoritative and I don't know, not rude. Don't ask generative AI to be rude, but something like more straightforward and straight. Yeah, you control this as well. Also, we can, I mean, it's not a requirement, and pretty much neither of these components are any kind of requirement. We just talk about generic structure, generic format. So we can also ask be specific with the target format we expect as a response, or in other words, prompt completion. So in this case, we ask to not just output as a text, but to form JSON object. Those of you who develop things, you know JSON format well. This is simple format for any kind of objects. And looking at this example, we clearly see that, yes, most likely the result of this request will be passed to some next chain of processing in our application. I mean, this is not will be directly exposed to the customer who requested this review. We can also provide example of what we expect. And in this particular scenario, intentionally, this example plays two roles, or at least two roles. First of all, yeah, it acts as example, like example of text we might want to hear back from this request. And at the same time, we double down on format of JSON object we expect. And this is like one more reminder, one more like nudge to the model. Yeah, be as specific as possible with format we provided. Otherwise, I mean, otherwise we can have trouble with parsing this object on the next steps of this processing. And we triple actually on request of JSON format, because we have one more reminder in form of Q, like JSON output. In this case, we do not double down on exact format, but just remind one more time that we expect JSON. And you will see very soon why we want to repeat some of the prompt components in different ways. After all, this is how we human look at the prompt. And this is how LLM is looking at the prompt, because, yeah, of course, computers understand this, this piece of text completely differently, right? And before doing anything else, large language model splits prompt you send to it into tokens. We don't have chance to dive too deep into what exactly token is, because this is more from data science field, more from like how people build large language models. But in very simple words, tokens, this is the way model consumes data for training, and correspondingly, it's the way it outputs data. I mean, model do not understand like words or concrete characters. No, this is something in between. As you see on this example, and I intentionally colorized tokens with different colors. I mean, color itself means nothing here. This is just for visual distinction of how many tokens in this particular prompt. You see, in some cases, one word is one token. In some cases, word split into multiple tokens. And again, to simplify to maximum, we can say that the more often particular word was met in training data, the more chance that it will take only one token. It will not be split into tokens. You might ask me, Maxim, why do we ever have to care about all these internal things? I mean, we just want to send prompt and get something back. Yes, but tokens are crucial in a couple of things when you interact with large language models. And first of them is cost efficiency. If you remember, in my definition of prompt engineering, I explicitly have being cost efficient. And in mainstream scenario of you using generative AI endpoints or large language model endpoints exposed for by some vendors, I mean, it's for the case when you are not hosting the model yourself, but using some say a third-party service, for example, exposed by OpenAI, for example, exposed by Azure OpenAI, exposed by Google Gemini APIs. I mean, something that where you don't own model itself. And in many cases, we talk about huge and the most advanced, most capable models where like there is no chance to ever host this model somewhere on your server in the basement. Yeah, so discussion about tokens becomes crucial when we want to understand how much will it cost to us, because again, there might be some small differences in how you are charged for using these models depending on this or that vendor, but mainstream and like main case is the following: you pay for number of tokens you send and number of tokens you receive. And of course, then you multiply every single number of these API calls you've done, right? And it makes APIs that expose large language models quite different from all other APIs, at least the ones I worked for. And I mean, this is just how it works. You just have to keep this in mind. It's not really big deal, but again, to estimate costs, you have to consider this. These technicalities. And also, this is what you see on the screen now is example pricing table for one of the services. I took Azure OpenAI service. You also see that price per 1,000 tokens is very different depending on the model you interact with, and it might be a few orders difference, and we'll go back to the discussion about which exactly model you want to use in this or that scenario. I mean, of course, it will directly affect your final bill. Do you send your request to GPT-4 or GPT 3.5 or maybe some completely other vendor, not OpenAI, not Microsoft? Keep this in mind as well. One more thing I want to mention here is context. or context window. It's in form of separate column, and this on this slide, and this is where we go back to importance of understanding how many tokens you send, because even if you are not limited in money at all, which is, I believe, quite fantastic scenario, right? You still cannot send, let's say, full set of Harry Potter books as one prompt. I don't know what kind of scenario you might want to ever need this, but for example, if you want to either summarize everything or maybe write new book based on all available books, I mean, this is just technically impossible because there is always limitation on number of tokens you can send. And as you see on the screen now, I mean, we are not talking about dozens or hundreds of tokens. No, it's thousands of tokens or tens of thousands of tokens or hundreds of thousands of tokens. And most capable model, not on this screenshot, but from other vendors, can accept up to 1 million tokens. Still, I mean, you can send like string, paragraph, maybe like some number of pages, maybe a whole small book, but not something unlimited anyway, right? And of course, keep this in mind as well. Good. So I hope that I emphasized the importance of understanding tokens and how can you understand how many tokens this particular prompt will take. There are a bunch of what we call tokenizers that will help you to just get, I don't know, information about this particular prompt contains this number of tokens, and also keep in mind that different models tokenizes differently. I mean, when you want to estimate number of tokens, you must also provide what kind of model and maybe even version of the model you want to interact with. Now, let me start introducing some tips and tricks and some methodologies and some techniques. Back to model selection strategy. So you've seen that prices are very different, and yeah, different orders of magnitude. And yeah, by the way, let me go back here for a second, because I forgot to mention that compared to many other services you use, this one has strong tendencies, has strong trend to become cheaper. And of course, I mean, this affects in very positive way on your like business estimations, business evaluation. I mean, if you are a startup working with generative AI and calling these third-party large language models, sometimes you need to recalculate your economy in a more positive way. Because if you talk about they are getting cheaper, they're getting cheaper 2 times, 3 times sometimes. So just follow the news, and also follow news about newer models. If we talk, if you go back to our discussion about GPT 4.0 introduced maybe 1 week ago, it's not only smarter, it's also faster and cheaper. I mean, this is just win, 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 win. I don't know how many wins for the developers. But let's go back to model selection strategy. How do we pick from this plethora of models available for one provider, or even more complex if we are free to choose multiple providers? Start from the most capable one. This is the straightforward recommendation. Write your best prompt. Find the prompt that delivers the best possible results from the most expensive model. Then you try to downgrade the model, and in many cases, the request you sent will be totally similar. You just change, like, for example, host of deployed model. I mean, switching between different models is not technically challenging at all. So you try to downgrade to a cheaper model. Maybe prompt behaves the same. That's the best situation, right? You don't need even to change this. Or you can try to fine-tune this a bit if you are not happy with the results that cheaper model delivers. Yeah, if after this downgrade and maybe first iteration of tuning, you get results that are not worse than the ones delivered by the most capable and thus expensive model, you have like 2 choices, right? if results worse, right, and you cannot achieve same level of I don't know, efficiency of the results, you have only one chance to return to more expensive ones. If results are same or even better, you can continue downgrading and you can continue saving, and maybe you want to run next iteration of this process I described on even cheaper model. Plus, in many cases, if we talk about real-world applications that use large language models, it's not only about calling only one time of this generative AI point. In many cases, this is kind of chain of calls if you build something beyond hello world scenarios. And also, you're absolutely free to mix models, even different from different providers. I mean, either models from one provider or completely different one. Of course, you get more like fragility in your solution, in your backend. But still, I mean, you have to find the balance. And for example, for kind of expensive scenarios where when we normally like generation is something that most expensive, more capable models do the best, so you can use these ones. But for simpler tasks like categorization, classification, I mean, smaller models and the less expensive models can achieve results that are satisfactory for your particular solution. And also, you can chain in slightly different way. So you remember that we can save some dollars on shorter prompts, and why not to ask summarization of, for example, if we talk about scenario when we need to send some kind of text block, maybe some pages of text, we can ask cheaper model to summarize this before, just to compress this a bit before sending. And let's continue our discussion about space efficiency, about token number efficiency, if you wish. A couple of very concrete recommendations from my side. Have a closer look at such small things like white spaces. I mean, normally we don't care about this too much, right? When we chat with our friends, when, I don't know, we send some messages, but not in this case. Even though prompts are like looking like human language, natural language, and in the big picture, number of white spaces you send will not affect, at least dramatically affect results, but it might affect your price tag again, because some models, they consider every single white space you might accidentally add as a separate token. Of course, I mean, yeah, you will notice this if you send these prompts at scale, but anyway, please keep this tiny trick in mind. You might also try various formats for different types of the data you supply with the prompt. The best example I have to illustrate this recommendation is how we supply dates. As a developer mind, as technical mind myself, I might think, okay, I will shorten this to the minimum and I will use the shortest data format, like you see on the bottom row of my illustration. Bam! It doesn't work like this in this particular situation for this particular model. I don't remember what I used, for example. Maybe this was GPT 3.3 or 4. Different models tokenize slightly differently, I mentioned, but in the big picture, it might work like this. So suddenly, the most efficient format in terms of number of characters is the worst efficient format in terms of how it will be split into tokens. And suddenly the regular kind of human date format that is on the first string is the most efficient one. So it takes only 3 tokens compared to 6 tokens if I tried to compress. There is no any kind of rule here, unfortunately. So the only recommendation here is experiment, try different formats. And if we talk about format for tabular data you want to supply as a part of the prompt, quite often scenario, tabular data is quite efficient. I mean, no need to recreate the kind of JSON-like format when you provide caption for every piece of data you supply. No, just use table as table. For example, use table caption as the first line and use pipes or tabs as separator, and then on the next lines just list the exact data points. Also, it might be different from language to language, token efficiency. And of course, it's all connected with the fact on which models were used for training this, which languages were used for training these models. Of course, mainstream models mainly trained on English, and those prompt you send in English language is I don't want to say always, because yeah, I cannot guarantee this, but in vast majority of scenarios is more token efficient if you compare to the same prompt translated to other language. Of course, it doesn't mean that you have to only use English in your prompts, and in many business scenarios you have to use different language. But again, keep this in mind, and if there is a possibility to switch, or like experiment and see what works better. Now, I want to start introducing some tools, and expect many more names of the tools without diving into too many details about concrete tool, concrete library, concrete solution. So this will be your homework. I mean, if something interests you, go and check. And all the tools I share today are free, are open source, and like you can start using them immediately. If you talk about token efficiency again, in some cases, you can get same or very close to same results from the prompt if you compress this prompt. I mean, I mentioned multiple times that we write prompt using our natural language, but again, based on lots of research, it happened that you can, let's say, extract key components of this prompt and send it against, so instead of full version, to get, again, maybe not exactly the same, but same level of satisfaction results. And this tool does exactly something like that. Prompt compressor called LLM-Lingua, developed by my colleagues from Microsoft. How that works, it uses another model to actually compress the prompt, and this model is model used for compression is small, like intentionally small, right? I mean, you can host it locally, you can host it like on your own server. I mean, you don't need to pay like extra for this compressor stage of the story, and you can achieve up to 20 times compression with minimal performance loss, because of course, yeah, there is overhead, right? Both in terms of what kind of prompt will be, or what kind of completion will be resulting, and also it's still about sending one extra call, right? But also keep in mind, I didn't say this explicitly, the shorter prompts normally let you give results faster, and you can compensate this performance loss by using prompt compressor. If we go back to example of our prompt we used for going through token anatomy, I just went through this compressor like with all default parameters. I mean, I didn't play with this at all. Maybe it could be even more efficient, but this is what I got. So you see, it's still somehow readable, right? I mean, it's still not programming language. It's endlessly far from this, but all, let's say, maybe secondary words, maybe secondary statements were removed from initial prompt. It made it shorter. I cannot guarantee that it provides exactly same results as output, right? But again, we are about finding the balance. If results provided as output of this compressed prompt are still doing their job and still good for my solution I built for marketing automation, I can save some dollars by just having this compression front end before my prompt. And of course, Yeah, I mean, you cannot just go and do compression yourself as human. All these compression algorithms are actually also not like straightforward algorithms, but also result of work in another generative AI endpoint, this small large language model I mentioned. Oof, let's go further. And this is where I want to introduce some general recommendations on prompt engineering. Be specific and clear in your prompt. At the same time, be descriptive, and you might want to use examples. And again, we are not talking about like hello world kind of prompt, right? We are talking about the nitty-gritty details of the most ever efficient prompts. Efficient both in terms of output it gives and number of dollars you spend on using these prompts. Sometimes you might want to play with order of prompt components. Again, there are no any kind of predefined rules, maybe except one, and this will be listed on my next slide. Sometimes you might want to double down on some components of the prompt. And if you remember example, again, from this marketing automation tool we built all together, I repeated a couple of times about the format I expect. Another recommendation, and this one specifically for the scenarios where you not generate something, but ask model to categorize some piece of information into some like large buckets you provided. In many cases, you better say very explicitly in the prompt, if you don't know or you're not sure about where to put this this item, you better say I don't know, instead of kind of forcing put this into one of the categories you provided. Now, a bit more technical recommendations based on the general ones. This is what I meant by saying there is pretty much only one approximate recommendation on the order of prompt components. Normally, you want to start with the instruction, and in some cases, if you are unhappy with results delivered, you might want to repeat it at the end. So using same words or different words, experiment. You might want to clearly separate prompt components, and there is no any kind of predefined or required syntax. No, you can use all kinds of separators you have in your mind. Normally, I use, for example, 3 minus signs or 3 hash signs to separate like data from commands and everything. But yeah, the more clear you with this separation, the better chance that model will really understand your intent. Don't try to multitask. Prompts are kind of single responsibilities things, and if you have 2 small tasks you want to complete, you better send 2 prompts. And also, if we talk specifically about models exposed by OpenAI, via OpenAI directly or via Azure OpenAI, in addition to prompt, you can send couple of, not couple, actually there are more of parameters, but these 2, they directly affect kind of level of creativeness of LLM, and you can control either to have more deterministic results. That means, more or less same results every single time that you send this particular prompt. Or if we talk about use cases for generation of something, you might want to tune these parameters to the full maximum to unleash full creativity of the model. Also, I mean, I mentioned multiple times about you have to experiment, and we'll repeat it 100 times more, I believe, during today's session, because it's all about experimentation. There are not so many, let's say, strict rules to follow, of course, with all pros and cons of this situation. Now, a bit more concrete techniques on prompt engineering. And in many cases, it all starts with your decision to go 0-shot versus few-shot prompts. And by shot, we explicitly mean here, in this particular situation, example. Let's have a look at another imaginary situation. Of course, like simplified, but the use case is absolutely real. We have insurance company, and we want to build solution that is kind of first line of support. And just imagine that, for example, we got call or email from our customer, and if it was a call, we can even transcribe this to text using the same or different API and like LLM API endpoints or just AI endpoints. And after all, we have a text, raw conversation, and or we can call it customer question. And we have multiple departments in our organization. Department that is responsible for auto insurance and department that is responsible for home flood insurance. And we want to understand which department to send this request to. I mean, just to avoid human job on this stage. And of course, this can be easily automated by using generative AI. So what do? We create solution, and one of the core prompts of this solution will be something that you see on the screen now. Classify or categorize, you name it, customer question. And we have categories and we have customer question. I mean, colorization of this example is just to differentiate different parts of the prompt, but after all, this is one single prompt you send to endpoint. And by the way, this even this very small and synthetic example showcases one of the best practices I mentioned. Maybe you even noticed this, and this is about giving model an out. I mean, if model is unsure, is this particular question about auto insurance or flood insurance, we better say it's not relevant to insurance at all, and then maybe this is where human intervention will be needed, instead of force putting this to one of the departments, and I mean, then people from this department can be totally confused, right? So just follow this best practice. So in many cases, prompt like this will work fine, but in order to have even better results, you might want to inject one more component into the same, like one unified prompt. And this is examples where you, in the one prompt, again, this is the same prompt, colors are just to differentiate prompt components. If you enter like 2, 3, 5, I don't know, experiment again, number of examples, most likely you will get better, more predictable results. So this is all about zero shot versus few shot prompts. And of course, this is, I mean, there is always compromise, right? Because zero shot might not work perfectly, but it's cheaper than few shot just because it's shorter. It's a smaller number of tokens. So you have to find your own solution for that. Then next methodology I want to share, called chain of thoughts or reasoning in other sources. Another example, a prompt that is asking large language model to do some math, to solve some math problem. And first of all, disclaimer, large language models are not the best way for you to send them tasks like this. This is 100% synthetic example, but anyway, it illustrates this technique that is applicable to many more cases. It's just the simplest way to illustrate this. So long story short, white text in before section, this is prompt. Blue text, this is response we got from kind of generic LLM. We are not going to dive into solving this math problem ourselves. I just tell you, the answer I highlighted as red is incorrect for many reasons. Again, we are not diving deep into how LLM work, but to simplify to maximum, again, it tries to find the lowest hanging fruit answer, the most probable answer based on your prompt, and for this particular math issue, it's endlessly far from the correct one. But if we use the same prompt in after section and add just one more sentence to this prompt, and it could be something like, let's think step by step and explain calculation step by step. Something like that. I mean, this is not a dogma to use exactly this wording. You will find your own ones. But after we asked model to be a bit more explicit, Yeah. First of all, we have slightly longer response, right? This is, after all, we asked to do calculations step by step. But what's more important, the answer is now correct. I highlighted this as green. So a very interesting and important technique. Next technique is basically not about writing prompts itself, or writing prompts as such, but writing applications that use prompts. And I already mentioned that if we go beyond Hello World examples, in many cases, to build something like something valuable for your customers, you might want to chain the prompts, to combine different models. And I just want to remind that you easily can use results you get from one call of particular prompt, a particular model with particular prompt, as input or part of the input for the next call. For example, this could be totally different model, totally different even vendor of the model, or it can be your locally hosted model. You remember about model selection strategy, and this is where you can again pick parts of the models that they shine with the most. For example, if you talk about cost of the call, or model that is better in categorization, or model that is better in generation, just keep this in mind, that it's totally fine to do prompt chaining like that. I mean, again, don't try, if you talk about more or less complex scenario, calling one particular model cannot be the optimal solution, optimal in terms of results and optimal in terms of cost. Next technique is about splitting prompts into multiple parts. Going back to my imaginary example of you want to generate a next book about Harry Potter based on all previous ones. As I mentioned, there is no chance to submit all text as one prompt, but maybe you find a way to split this huge, I don't know how many millions or tens of millions or hundreds of millions tokens you get, after all, split into some digestible chunks. And of course, you check technical capabilities of the model. Every model has this context window limitation explicitly mentioned in the documentation. So you build up chunks of the size, and what you can do, you can ask summaries for every single of this chunk, and then you ask summary of the summaries. Again, of course, please don't ever consider example with Harry Potter. It's not about that, but still, if you talk about like large company documents you want to summarize, this could be a very helpful solution for you. And of course, I just mentioned you just split it somehow, and in reality, it's not that simple. I mean, definitely to have let's say thoughtful and intelligent chunking, it's not about just picking a number of characters from this word and then split by number of characters. You end up with broken words, broken sentences. No, you have to find some mechanism, but that definitely goes beyond our today's session. Sorry. Another very interesting technique I personally discovered myself quite recently, called directional stimulus prompting. This is where we actually help model a bit to, again, provide us with results we want, we expect. Example again, we have some input text we want to get summary on, and we also have reference. Reference, this is not something outputted by model. No, this is reference, like wrote kind of the best possible summary of this text, and this reference is written by human, because yeah, after all, we decide the level of model efficiency, right? Is it following our expectation or not? If we send this prompt as is, like prompt, summarize text, summarize this input, we can easily get model output like this. Yes, it's definitely some kind of summarization, right? And in many cases, I mean, this summary is still good summary, but maybe, I mean, good, but not ideal. And there is a framework called Rouge that is exactly to give you some tangible estimation how model output is good compared to the reference one. And you see that what model outputted is quite far from the reference, even I mean, without using any kind of tools to get this number. Just by comparing these two things, we can see, yeah, we could be better. But what if we, in addition to input text, in addition to our order that is summarized, provide quick hint, like focus on this, like value of fact or something, then of course model output is completely different. It closely, it follows reference much closer, and even like number, this formal number is much higher. That means that we got better results. Of course, again, devil is in the details. How exactly we got hint that we need to supply. And again, back to conversation about prompt chaining, about using different models in one component of your application. For example, imagine that we have very specialized model that is here to extract key entities from our summarization. Again, it could be not even large model, it could be small model hosted on the device or on our server. It could work very fast because it's highly specialized on something. It's not general purpose model, it's this one. So once you organize this chain, you have better results and most likely faster results, maybe even cheaper results, depending on slight like different scenarios you can organize. And yeah, just have a look how to provide this hint. Now, I didn't mention one kind of negative side of all our interactions with large language models, especially in enterprise context. And this negative side is basically affecting many solutions in a very, very bad way. And this particular term or like negative feature even deserved to be a word of the year according to Cambridge Dictionary, and this word is hallucination. And this is something that yeah, that many companies, many providers of large language models struggle with, and many large language model applications developers struggle with. And this is about models sometimes are too creative, and sometimes they are lying, they are making up facts. And the worst case, the worst thing in this, they are so convincing in all these facts that it's hard to identify this lie, hard to understand which part of the output are based on facts and which is completely made up by the model. And of course, you know, we have GPT model exposed with us for almost 2 years. There are multiple ways to mitigate hallucination, to reduce this. And many of these recommendations are based on something that you already heard. And prompt engineering is playing crucial role here. For example, in addition to what we want from the model, we can also supply some things that we don't want to hear from the model in the same prompt. Back to my recommendation to give model an out, don't forget that this will also reduce hallucination in terms of, for example, when model categorized some item completely incorrectly. So just be explicit in prompt by asking something. If you don't know, you better say, I don't know. Sometimes even very naive sentence like don't make up facts can still make a difference. Sometimes you can be like more demanding from the model, and you can, in addition to your like order, say, before answering, check if you have all needed information. And yeah, maybe like if model answers you, no, I need more information. Yeah, it will involve some extra work from your side, from your solution side. But anyway, it's all to reduce hallucination. Actively use step-by-step reasoning, this chain of thought methodology, and asking model explanation to think along the way how it outputs answer. But all these points are just toys compared to the last one I want to introduce in this list. It's about being very explicit in data you want model to use to give you an answer. I mean, if you want large language model to base their response, their completion on some data you have in mind, you just directly supply this data straight in the prompt. And again, seeing is believing. This is example, and this is next example of imaginary solution, again, supported by tons of real world use cases. It's about us building internal system for like company employees, for them to better understand their coverage of medical insurance. So just imagine that we want to build some internal chatbot, and instead of going through tons of different PDF documents written in, let's say, lawyer language, our company employees can just go and ask something like, does my health plan cover annual eye exam? I mean, this simple fact can be ditched somewhere in long documents. And also, as you see on the top of this prompt, we provided some like preliminary information, like you are intelligent assistant bot that is answering questions about insurance, and you can only use data provided below. And what we the rest for us is actually to inject this data, and we are good to go, right? We will get very nicely response based on exact facts, exact data we provided. Sounds trivial, right? Unfortunately, it only sounds so, right? Because, of course, the big question here, the huge question here, is how exactly we identify these sources of data. Again, of course, yeah, we can somehow try to extract all text from PDF documents and paste it here where we have sources section, but definitely this will be endlessly far from cost efficient, and most likely you will not fit into context window. You need extra intelligence layer or level to actually extract this data. How to find these 3 sentences from these hundreds of PDF documentations that include something related to the question about eye exam coverage. This is where next pattern comes to the play, called Retrieval-Augmented Generation, or RAG. And yeah, this becomes absolutely widespread term in all things related to generative AI. I mean, you heard about this a lot, for example, in the keynote of Microsoft Build. And I mean, in many cases, it's not even this term just used as abbreviation, RAG. So, and people do not expand this, but when they say RAG, you just keep in mind that it's about retrieval augmented generation, and it's basically about answering your question, how to actually get this data I need to paste into my prompt. And of course, there are multiple ways for you to do this, starting from the trivial ones, trying to extract keywords from user question and reaching out to your maybe like kind of conventional database, create some SQL query based on these keywords. But if you talk about something real and something efficient, in many cases, we are talking about calling large language model one more time, like before actually sending this nicely compiled prompt. We call large language model specifically for the point to extract data from extract needed data from our knowledge base. And unfortunately, we cannot dive too deep into this topic, but just a couple of things for you to crystallize in your mind for further exploration. It's vector search. So we take this customer question and vectorize this, and then we kind of compare this vector against vectorized knowledge base we have, and that gives us best of the best results. For example, if we want to pick top 3, top 5, top 10, depending on your use case, documents from our huge knowledge base. This is exactly where vectorization shines. But yeah, in the big picture, RAG is about extracting your data first and then just pasting your data to the prompt and sending it. And first component of all the story is the most technically challenging. Then just paste a couple of strings and send this full prompt to API endpoint. So yeah, we use LLM here and there. I mean, at least 2 times. And again, this could be a totally different large language models. And in many cases, they have to be different. For example, the one that is vectorizes is completely different to the one that is answering questions. And of course, in the real life, it might be much more than just one source information you want to look up based on even one particular question. If we look at, for example, building chatbot for your outdoor sports e-commerce web shop, yeah, even based on a question from the user, will my sleeping bag work for my trip to Patagonia next month? We can extract lots of details from this question. And especially if we know something about user, if the user is logged in, we can do even more estimations about what kind of source information could be useful for answering this. And then by pooling all the data from multiple sources, we form like one big prompt to any kind of generative AI model to actually get nicely formatted answer. And of course, you don't want to implement all this manually, like as a developer, like request by request, chain by chain, I mean, completely manually. And we want to actually have great developer experience for all kinds of applications we build to interact with LLM. And we before this point, we focused only on writing the prompt itself. But if you look at a bit larger picture, so I mean, you need some machinery to send this prompt and to get response and to parse this response. So we, in vast majority of scenarios, we are talking about building some backend. And of course, if you talk about, again, real world scenarios, it's not just sending one-shot request, right? We have to think about how we prototype, experiment, iterate, where we deploy, how we monitor, what are the ways to optimize, because yeah, this prompt works now. Will it work for the next model that is, for example, cheaper? Can we run this experiment somewhere? I mean, we are opening many more questions when we start building real applications. And a few tools to mention here, just briefly, again, just as names for you to explore further. A couple of them, LangChain, or like language chain, and Semantic Kernel will help you to orchestrate all your interactions with LLMs. I mean, it provides very convenient abstraction level for the developers, where you operate, like, let's say, higher level abstractions like agents, like plugins, without thinking too much about all these, you know, under the hood details, like parsing JSON, sending HTTP call, or trying to organize some kind of memory for stateful operations. Yeah, have a look at these 2 libraries before you ever start building your application. If we go one layer over this developer part of the story, and if we talk a bit more about operations that are also involved in building solutions, we have even more open questions, right? Because it's not only about like sending your requests and chaining all this and getting a nice level of abstractions here. No, we want to have full-scale prompt operations or prompt ops, or to be a bit more general, LLM ops in this case, that is ready for continuous integration and delivery, that provides us with versioning, it's code first, and yeah, all these tools that we normally have in IT projects, but mapped specifically to kind of different way we think about building LLM applications. Just one more tool I want to mention here in this context is called PromptFlow, also developed by my colleagues from Microsoft, also available both as open source solution and hosted solution. And as you see, it's like 100% code based, even though it includes a very nice UI in the form of extension for VS Code. If you prefer just writing the code, write the code. And it lets you think about your part of application that is about interaction with LLMs like a flow, or if you wish, graph where each node is either a call of particular LLM or some piece of Python code, for example, to parse JSON, or selecting the prompt from templates of the prompt you predefined. Then yeah, RAG template applied to PromptFlow framework could look like this. You have node to create embedding, you have node to send this embedding to your knowledge base, you have node to parse results from this call to your knowledge base, and you have node to actually paste these results in a prompt template you have, and after all, your final prompt to send the call. So you see that it's all editable. You have full control, and after all, you can just go and deploy this flow to some server and call this flow as API endpoint. And yeah, this is developed by Microsoft, but to give you full picture, I want to name similar solution from another company, Agenta. Agenta, yeah, your end-to-end LLM developer platform that allows you to, yeah, also think about your LLM operations in a similar manner. I mean, just another product for you to have full picture. To finalize and to have some time for your questions, I want to list learning resources. Of course, all of them are free. And yeah, this is PDF with the links, right? I mean, I'll ask organizers of this call to make sure that this PDF is shareable with you, so you'll get all these slides and all these links available.